Okay. So you got your balanced equation of CaCO3 plus 2HCl, which goes to CaCl2 plus H2CO3. Okay. So the next part you got to do is use the grams of known calcium carbonate, and you need to find the number of moles of HCl that you have in the beginning. You can do that by converting the grams of calcium carbonate in the beginning by converting that to moles, and also doing the same with the number of moles left over of calcium chloride carbonate in the end. So you convert those to moles by just taking 5 grams and then you do the factor label method, so it'd be 5 times 1 divided by 100.1 grams, and that'll give you an answer of 0.0499 moles. Okay, and that's the starting amount of moles of calcium carbonate that you have, 0.0499 moles, and you get that by, again, just taking the number of grams that you have in the beginning and multiplying it by the molar mass of calcium carbonate. Okay, so now you use I use a BCA table, which is before, change, after. In this instance, they give you the before and the after, so you need to find out what the change is to be able to find out the number of moles of HCl that you initially had. So you also do the same with the after amount of moles of calcium carbonate that you have. So you do the factor label again. They tell you that afterwards you're left with 1.9 grams of calcium carbonate. You convert that to moles by doing the factor label. You just times it by 1 over 100.1 grams, and that'll give you an answer of 0.0189 moles of calcium carbonate. And that's how much you're left with again. So the way you get your change, which is also basically your number of moles of HCl, just by a different factor, you'll see, is by taking your initial number of moles of calcium carbonate and subtracting the after amount. So you do 0.0499 moles minus 0.0189 moles to get a number of 0.031, I think. Yeah. Okay. Now what you do is that's your change of calcium carbonate. That's the number of moles that the calcium carbonate dropped before the whole thing finished. So the way you get your number of hydrochloric acid moles is that you divide it by the coefficient in front of the calcium carbonate, and then you multiply it by the coefficient in front of the HCl. It's just what you do. You divide it by the one that's on top of it, and you times it by the one that you're trying to get. So 0.031 is the change in moles of the calcium carbonate, and so you divide it by 1, and then you times it by 2 to get your number of moles of hydrogen chloride, or hydrochloric acid. So when you do that, 0.031 divided by 1 times by 2, you get an answer of 0.0155 moles. And that's how much hydrochloric acid is there, or that was there, because all of hydrochloric acid is going to dissociate. It's going to all go into solution, so you know that it's all being used up. Okay, so that's the number of moles that you have. So now you're trying to get the molarity, so all you do is you take the milliliters of the unknown HCl, and you just take your moles divided by your liters. So to be able to get liters of HCl, because you can't just take the moles divided by the milliliters, you gotta do moles divided by liters. You just divide 50 milliliters by 1,000, and that's just the conversion factor to get it into liters, obviously. So it's 0.0155 moles divided by 0.05 liters, and that gives you an answer of 0.31 moles per liter, or a molarity of 0.31. And that's how you get the molarity of the unknown HCl.